And this is for the webcast. So webcast begin, 3, 2. All right, folks, welcome to CS10 Lecture 2. We're learning about functions today. Woo! All right, bring the energy. So we always start the class with a discussion of computing in the news that's relevant. We're not archiving this because this will be old news by the time this class launches next fall. But the news today is you're learning about how to work with functions. We kind of gave you a little taste of what functions are, the function machine last time. If you live in this functional world where everything looks like a function, then that's called functional programming. And the news of the day is that chip design savings can be had from using this wonderful functional language. So researchers have discovered how they can prove, I'll read the quote, makes it possible for a chip design transform to be completely error-free. Meaning you're building a chip and you want to prove that the chip you're designing has no errors, logically or current leaks or any problems with the chip design. And you can prove it using this beautiful language. If you just code in this language, the proof comes for free. It's amazing. So there's a lot of money savings that can be made in terms of designing these chips. You don't need to worry about the details. If you actually care about the details, think to talk to a double E major who's in a VLSI class actually designing these chips. But the idea is this functional language, the basis of which you're learning today is going to yield these savings. So it's all about the functional language, and you're learning about what functional languages are today. So go functional languages. Yay. All right. And there's an XKCD comic over here, which is about functional programming, which you can read about. All right. So I'm Dan Garcia. If you missed the first lecture, I'm a senior lecturer here, and I'm really delighted to bring CS10 to all of you. Whenever you see the slides have this cal on the corner, it means it's local cal information, not archival, but I'm talking to you. And it means that you can ask a question, right? This is the time we're kind of having the local stuff where it feels like a normal class. So I wanted to add some clarity to what you're doing over the course of the week. There are many things you do over the course of the week. On Sundays, you do your reading. Mondays, you come in for lecture. Roughly Tuesday's lab. I know some labs are Mondays, some labs are Wednesdays, but roughly Tuesday's lab. Wednesday lecture, Thursday lab, Friday discussion. What do you do what when? And here's the important piece. In lecture, and this has come up many times other years, so I want to be very, very clear what the goal of lecture is. The goal of lecture is to give awesome demos. The goal of lecture is to be able to answer questions live. As I'm teaching you new material, I'm right here as the reference point to answer any questions you might have. The goal of lecture is to inspire you. The goal of lecture is to bring in awesome guest speakers for a really awesome, explanation of different fields of research or different really cool ideas that they're going to share with you. But every year people say, you didn't teach me how to code in lecture. And that's not the goal of lecture. The goal of lecture is to do kind of high order level, but the deep learning about programming is going to happen in your homework and in your projects and in lab. And you can ask the questions of the things that are confusing on Piazza and in discussion and in lecture 2, but really lecture is not about the coding details. So please, in terms of expectations, we're going to do very high level things in lecture, and that's fine. That's by design. It's not like I forgot to teach you the details. Details happen other places. And in fact, everyone tells us that the deep learning, if you ask every TA who's been through this class, the deep learning happens when you're doing it. When you're actually in lab working, in projects, and in your homework and with your partners. Deep learning does not happen in lecture. If you go I've been out of school many, many years, having my 30th high school reunion. I don't remember what happened. I remember the things I learned were the things I learned from doing my homework, not from the things I remember them saying to me. Hearing something does not lend for deep learning. Doing something yourself and caring about it lends for deep learning, just for your own edification. Okay? Questions about that? Because we're on a cal slide, you guys can ask questions. Questions about that? That's kind of just kind of setting the expectations. Also, I mentioned this last time, but it's begs repeating. Your office hours and discussions have no limit to the room size. The only thing that limits to the room size is our labs. So that's the ones we can't just have everybody decide to do the common, most popular one in the middle of the day. So if you want to go to my office hours and that TA's office hours and that TA's office hours and that TA's office hours, it's awesome. You can go to as many as you want. People often think that you can only go to your TA's office hours. That's not true. Go to anybody's office hours. In fact, come project time, when you're really struggling and you can't get it to work, bring your broken project on your laptop to all the office hours and try to get as much help as you can. So the goal is to give you a whole sweep of people to help you, as well as Piazza. But I should say this, not on the slide, but this is important to mention also, don't ever post code on Piazza. Because what will happen is you'll say, here's my code, I got 99% working, what's wrong with it? And someone who else who hasn't started yet then can look at your code and steal your answers, and that's not good. So we don't want to have any issues of, people sharing answers when they're inappropriately done. So please don't post code. You can actually post a private note. So Piazza lets you post a private note, and if it's a private note to only the instructors, then you can include the code. But we're not going to just fix your code for you. We're going to teach you how to do it. So it actually makes much more sense, and our TAs prefer you go to them live, because they'll teach you the process of debugging rather than actually hand you the answer. There's a common phrase I'm sure you've heard, give a person a fish and they eat for a day, fix a person's bug and their bug's fixed for a day, teach a person how to debug, teach a person how to fish, and they debug and fish for a lifetime. See? With the fishing, debugging, and okay. So including if you're fishing wrong, you can debug your fishing if you want. Okay. So, and for me personally, this week only, my office hours are going to be on the website. So please do check cs10.org for all the information. We try to keep it updated. It's a really nice calendar app that we have on our website to figure out where you can go and what's available that week. It should refresh every week to have the current week in front of you. And my office hours this week started half an hour early. They're going to be Tuesday, tomorrow, 10 to 11. So please circle that. I'd love to have the students come in. I have a ton of office hours. I have a ton of space in my office for people to come in, and I will even get a bigger office if too many people come in. That's happened in the past where all of a sudden people have come in and it's more and more and more, and we're standing room only. I've gotten a bigger room. So we will all make bigger rooms for office hours and discussion if there's a lot of interest in that. Discussions, go to any discussion you want to. It'd be great if you go to your own TA's discussion so your TA gets to know you more. But if you want to hear it twice, if you want to hear what another perspective is, that's also fine to go to more discussions. The only thing you can't do twice is labs because we have limited space for that, okay? Any questions about lab or discussion? Just this is the open, or any other thing that happened in CS10 that I missed over the weekend that you had questions about. We're good? Yeah, please. Tell me your name. Diane, go ahead. Yep. The dates are off. There is a little left-right button that you can adjust and move the calendar left-right, so that might help. If you mean the larger calendar for the whole year, then we should let Michael know that we should check. We can probably fix that in real time if they're off. But thank you for letting us know. Is it on the big calendar with 15 weeks, or is it like the weekly, what's happening, what hour? Oh, the stuff is due. Yeah, the due dates might be off, but the homework 1, 2, and 3 should still be good, but the later due dates are probably off later. We're still working on those. Okay, but let's make a note. Michael's making a note. He's my head TA, so we'll make a note for that. Any other things that came up? This is the time. This is the free-flowing, free computer science, free love kind of discussion. It's Berkeley. Go ahead. Yeah. Oh, my goodness. If your lab class with your schedule, can you bring your laptop and go to another lab? If the lab has space and you have a laptop, answer is yes. If your TA says, yeah, we got room in the corner, and you got your own laptop, we bless that. That's a great idea. Yep, no problem. Other questions? Just to make sure this isn't like when we go filming and you feel like you can't ask questions, we have a lot of time for you to ask questions. By the way, you're going to get clickers this week. We didn't get a chance to do that because our TA meeting was Monday, so it'll happen this week in the Tuesday lab, Monday, Tuesday, Wednesday lab. I have clicker questions today, so we'll do a hands. We'll do it, but you get a sense of how I stop lecture and we have discussion. This is going to be the most interactive active learning class you probably ever had. And there's just a piece in the New York Times about how to make class active learning. I'm like, we already do that. I felt all smart. Okay. Any other things? Any other last minute things? Yes, name? Demise. Tell me. If you have an iClicker, you're good. You don't need to borrow ours. Yes, you can. If you have any other classes, all we need to know is your name to your number. Whether other classes have that same list, it's fine too. So we just need to know your name and your number when you register on the iClicker website. We'll talk about that later. But you need to our iClicker website, tell them you're in this class also, and we'll know that. Sorry, in B courses. You register in B courses. I'm sorry. B courses is the way you do it. Thank you. That was an old thing we used to do, but B courses is how you register. Good question. Excellent. Other questions until we roll in? All right. Good stuff. Okay, so I think the next slide is the beginning. Okay, so here we go. Let's look at my camera people. We got 5. I'm going to test out my timer. My recording's still going. Take a little drip of water here. Live to your audience. Here we go. 3, 2. All right, welcome, folks. We're going to learn about functions, and this is the basics of functions and why they're important. So you recall from the last video you saw that we talked about what a function machine is. And a function machine, like the picture you see right here, is almost like a sausage maker. You put in some input, like raw meat or some other things, and you turn a crank, and there's one output. Okay? That's a function machine. So you've learned that in theory in algebra. So all of you taking this course needed to have algebra. That's part of what we're supposed to have learned by now. This particular example I'm showing you is +5. So what that means is, let's watch it. N is the input. So y equals, see right here, y equals +5 of n. What that means is, n is your input, you turn the crank, and the output is 5 bigger than you put in. Okay, that's all. Very simple thing. It doesn't change n. If n were a variable with a box, it's not changing that box. What it's just doing is saying, I drop in the 5, I turn the crank, I drop in the value 5. I don't drop in n. I'm just labeling n so you kind of know what it is. I don't drop in n. I drop in the value of whatever n is, and then the 5 goes through. And at that point, n is lost. We don't care what n was. The 5 goes through, and machinery happens, and then the output comes out, which is whatever 5 plus whatever the input is. Okay? It returns a single value. So, my son recently was in 2nd grade, and this is a curriculum that came from the University of Chicago called Everyday Mathematics. And you'll see right down there, it says, what's my rule? And it says, look, a function machine. 2nd grade. 2nd grade. The function machine, the +5 function machine, where you drop in a number, turn a crank, and 5 more than that number comes out. And the kid's supposed to fill in a table. So I filled in the table for you, but 3 comes in, and then he has to fill in the right column. 8 comes out. 7 comes in. 12 comes out. 15 comes in. 20 comes out. Isn't that amazing? That was in 2nd grade. So same idea, but they're teaching kids nowadays. Boy, kids, whippersnappers nowadays, are learning functions that you're learning in algebra, and we're seeing again at the university level. And you, as a high school student, are learning this as well in this college course. Pretty exciting. So that's just context. So now we're getting to the actual definition. This is where the university course comes in. What is the definition of functions? And let's connect that with what you learned in math. Functions take in, as input, 0 or more inputs. It's possible to have a function that takes 0 inputs. Interesting idea what that might be. Normally they take in 1, 2, or 3 or more inputs. Here's the key. Functions have to have exactly one output. Exactly one. You can't have 2, you can't have 0, you can't have more. It's exactly one. You might say, well, Dan, what happens if I want to return 2 things? Well, somehow you take those 2 things and smush them together so you return that one combined, like put them in a bag, return the bag. That's the idea. Here's the other important idea. The same input must generate the same output, which means that function can have no randomness that determines its output. So if I put in 5 if I put in 10 to the +5 box, I better always get 15 out. There's no way I get anything but that. Okay? So people often say, how about the function date? Date might take in no inputs, and I just ask for the current date. So remember, the same input gives the same output. Date wouldn't work then, because date has no inputs, but every single day would be a different output. So that's not a function. Date is not a function. Okay? Here's some more subtle rules of what functions are. They can have no state. Whatever happened in the past, whatever the function was doing, whatever your program was doing, cannot affect what that function does. If the inputs haven't changed, the outputs won't change. It's ignorant of whatever the history was. That's part 1. Point 2, there's no mutation. That function is not allowed to change anything else about the program, anything else about the state of the program. State means what it remembers. So maybe some variables, maybe the pen on your plotter changed, maybe the sprite moved. No, a pure function is not allowed to do any of those things. Only inputs and a return value. That's all it has to do. That's all it can do. And the third thing, no side effects. And a side effect is anything aside from returning that output value. Okay? So it means that if your function is being sneaky and yes, it's doing +5, but also it's moving the robot. Not allowed. It's adding +5, it's also making the sprite move. Not allowed. It's putting +5 and it's also making a sound. Not allowed. The function can have no other effect. Only values in and values out. That's all it can ever do. Can't base on history. It can't change anything in the state of the computer. It can also have any other effects like sounds and lights and robots and that kind of thing. Okay? So, in summary, we've now seen what the basis of a function is. Connecting with your connection with math. Has some inputs, 0 or more, has exactly one output, and can have If the same inputs come in, the same outputs come out. All right? That's a function. Awesome. On to the next video. Great. Okay, now I have a clicker question. See, now we kind of go back to Cal, where we're engaging, and now you can rest and ask me a question. By the way, any questions about what you just saw? This is exactly the time where this comes up. I talked about a function. You think you kind of got to get it? Well, let's see if you get it. Ready? Here is a quiz. You normally would have had a clicker. And if you have one, I'm not running it now because nobody has one. But if you had a clicker, you'd be pulling it out, and I'd be running the clicker software, and I'd be saying, what is not a function? There's only one of these that's not a function. The four of them are, one is not. Which one of these things is not like the other? Okay? So, how many of you think A is not a function? Okay. We just do hands because we'll do clickers for real. I've got about 10. B, the next one down. B, go ahead. I see some hands. B, give me some love. There's this weird triangle guy, right? B, okay, 3 or 4. C, see, the nice thing about clickers is you can do this anonymously. You can be the only person to vote something you don't feel bad. C. Anybody with C? Anybody with D? Okay. How about E? Okay, the whole class, E. All right? Okay, the answer is A. Who got A right and wants to argue why it is? Let me see some hands. Yes, what's your name? Danielle. Danielle, go ahead, Danielle. 5 and 15, yeah. 7 one time. 5 and 15 don't change. Your inputs don't change, but every time you're running it, it's putting out a different number. It's the whole reason for being for this random guy, which is exactly the opposite of the definition of a function. Remember? Same inputs, same output. 5 and 15, 1 times 7, 1 times 15, 1 times 8, okay? So that was a pretty clean definition connection. Why is true a function? Most of you thought true wasn't a function. Why is true a function? Yeah, what's your name? Maddie, go. No, it's the inputs, and what does it return? Returns true, right, that's the true block. It's a click on it, it returns true all the time. That's all it is. Isn't that kind of cool? So if you ever wanted to get true, you click on it, you get true again. Click again, true again. Is that awesome? Always the same, standard definition, nothing's changing, true. Okay, clean on that? Awesome, right? Yes, and I got you, see? I want to give questions that kind of get you to learn something, and most of you got it wrong, so I'm happy. I gave a good question. Yes? Tell me your name. Brian, go. Output for B, you get to put values in there of like 3 is less than 4. And if 3 is less than 4, it says true. If 3 is less than 2, it's not. It says false. So it's a comparator. Who's bigger? Okay? All right? Good stuff, huh? Good stuff. Okay. So, take a little sip of water. Reset my timer. Stop. I'm doing pretty well in terms of making 5 minutes. Again, I'm going to keep you, with your quiet time for the video time for about 5 minutes, and we'll have a lot of time for talking. Really engaging. All right, here we go. Start. Okay, how's my camera? 3, 2, 1. With the Eric and the Michael, give me the thumbs. We okay? We're good? All right. 3, 2. All right, welcome, folks. Now we're going to talk about data types and domain and range of functions. So what you're going to see here is a list of a couple data types. And data types can often be drawn like a Venn diagram. It's kind of interesting. So we're starting at the bottom of this particular case. And by the way, these aren't 4 data types that came down from the tablets on the mountaintop. These are just 4 data types that I've seen and I'm putting names on. But there are many more. And there are more that you can make. You see the title of the slide says you'll make them too. You will make your own data types. And that's actually making your own abstraction. We talked before about an abstraction for traffic where you just have your XY coordinates of a car being your thing. You can make a data type that has an X and a Y value in a data type, and that is your own data abstraction. So you can make your own abstractions. You'll do that in this class. So I'm showing you 4 examples here. At the smallest level, the data type of letter is being used. So a letter is clearly capital A through Z or lowercase a through Z. 52 characters, that's it. That's a letter. Okay? Bigger than that, in a set space, bigger than that is a character. And a character says you have to have only one length. The length is only 1, but it doesn't have to be just letters. It could be numbers. It could be hash sign. It could be, the curses they always use for the comic strips. All those are characters. Okay? Above that is a word, which is more than 1 character. So I'm just a little bit bigger than that. So if I give you an input that says, Here's 5 characters that that we call that a word. With no spaces is important. The space can't be part of that. And larger than that is a sentence. And all that means is spaces are now allowed. That's all. So how about Dan? Is that a sentence? It is, because you can have no spaces in a sentence. Dan is your teacher is also a valid sentence. Okay? So you can have some number of characters with spaces if you want. That's kind of a general thing. Okay? So now that you know this, now let's see what the domain and range are. Now, domain and range may be new phrases to you. They come from mathematics. Domain means the type of input a function takes, and the range means the type of output a function is. So think of dr, like doctor. Okay, dr. So, domain. Let's look at some examples. Square root of. What would square root of be? Now, the answer you see here. But let's think it together without even looking at the slides. Look at me. Square root of. Well, square root is going to take, if I don't want to think about complex space, 0 or a bigger number. Not negative. I'm going to say that's illegal now, even though some square roots can handle that. This one can't so well. So we're going to say square root has to be a non-negative number. Okay? Doesn't have to be an integer. It could be 0.5. That's fine. No, 0.7. That's okay. So non-negative numbers, and the output is going to be also non-negative numbers. So that's kind of a mathy thing. Okay? Length of. So length of takes in, what does it say? Sentences, which really means also words, also numbers. And length of tells you how many total characters there were. Just like we said, characters are these things, including spaces. And so length of tells you how many characters total in that sentence you give it. Okay? So the output is going to be a non-negative integer. It's going to say 0. If you give it nothing, it's 0. Okay? If you give it a 1-character guy, it'll give you 1. If it says at, it'll give you 2. Okay? So that is length of. There's also a length, by the way, in the list, which tells you how many elements in the list. That's different color. This is green length of. We'll see it later. The less than block. Well, you think, well, less than can only obviously take numbers, right? But no. We decided to make our functions as general as possible. So less than takes numbers. It also takes letters and words. So if you want to, and why would you ever use this? Well, what if you had a list of words and wanted to sort them alphabetically? Wouldn't you need to know what word goes before what? What word's closer to the AAAA aardvark and what is closer to the ZZZ zebra? So you have to be able to compare which word is kind of less than that alphabetically in the dictionary. You use the same beautiful block. The same block you're using for numbers, you can sort numbers smallest to largest. You can also sort words from not smallest to largest in length, but from A to Z. Does that make sense? Isn't that kind of cool? And. Finally, and I'm showing you. So and is a block, is a function that takes into Boolean values. One of the kinds of values I haven't talked about before is a true or false value. It's only true or false. That's all it can ever be. And that's called a Boolean. So that true or false value is passed into both of the inputs of and the output is, yet again, a true or false value. Does anybody know what kind of true or false value it is? Like, how is it a function of the output? Yeah. So and says it's only going to return true if both the left and the right are true. They both have to be true, right? I want to have pies and I'm hungry. So I want pies and there are pies available, then I'll buy some pies, right? I wanted pies, pies are available. If neither of those are true, if I want pies but no pies available, I can't buy them because I can't buy anything. If pies are available but I'm not hungry, I don't want the pies. But I will buy the pies if I want pies and they're available. Make sense? Okay? Punch and pie. So that is domain and range for that example. So now I'm giving you, and this is the last slide before we cut it for this video, the 3 types of commands that we have in Snap. The first type is called a cookie cutter. We call them 3 types of blocks. I'm sorry, I'll say it again. 3 types of blocks. The first one is called a command. The command has this cookie cutter shape. And you place them and stack them one above the other. And they work one after the other. Okay? Top down. Okay? The second kind is called a reporter. And the reporter block is a kind, like a function, returns a value. So reporter is exactly like we're talking about in this lecture. Values come in and values come out. Okay? Just like a function. A predicate is also a function. It's a special type of reporter, one that returns only a true and false. So it'll help you as you write your program if you have an if. If this is true, then do that. Otherwise, do that. The first argument to the if is kind of this hexagonal shaped block indicating that better be a predicate. it better be a function that returns true or false. You can't put if 5. Doesn't really make sense. But if something is true, then I'll go buy the cakes, right? If pies are available and I'm hungry, then buy the cake. So we use the hexagonal-shaped predicate in the argument to the if. Okay, that makes sense? All right, so those are the types of blocks in Snap. You've now seen a couple examples of data types, domain and range, and some blocks and snaps. In blocks and Snap, you're almost ready to start programming. Awesome. Bink. All right, cut it. And now, I cut it too early. I forgot to say this thing. That's okay. We'll go back to, maybe we'll cut this together. And one of the things you'll see is procedures and subroutines are another way that people call all those blocks. So commands, which don't have a return value, they just do something, side effect, and the functions, those are all called by the more general population as procedures or subroutines. So in the APCS Principles course, you'll see the word procedure. And that means any kind of block, function, or command. Okay? That's the idea. All right? And cut. All right, so we sneak that one in. So what we've got here is another clicker question. See? Dynamic. Okay, first we stop and we ask any questions. I told you some four types. Actually, I did a fifth one because I did true and false. We did domain and range, and we did example of blocks. Questions about the material so far? So far, so good? All right, you think you're so smart? Answer this one. Go. This is really good. I'm trying to query you, not just kind of who has questions, but bam, here's a real question that might come from an exam, right here in class, okay? So, letter blank of blank. Okay, it's trying to like, you give it kind of you give it some input, and it's trying to find the, the ith letter of that. But I'm not going to tell you what those inputs are. I'm asking you, if you were to write this block, what would you have as the domain and range? That's what I'm asking, okay? Because that's probably what it's doing. So I'm really asking what it does, but think about the most general case you can for this, okay? So, are you asking, does it only work for numbers and integers bigger than 1? All of them are integer greater than or equal to 1. Why? Because we start indexing at 1. The first character is 1. In other computer science courses, they start at 0. Not here, because you start counting at 1. So for non-majors classes, we always start counting at 1. Lists are indexed by 1. The letter or the number or the character or whatever in a sentence, word, or number are start by 1. So would you take in numbers, words, or sentences? And if so, which would you return from your range? All right, here we go. So A. Numbers, it only works for A. Nobody. B. Okay, a couple. C. D. Uh-oh, now we're getting more general. And E. In general, by the way, everybody has to vote, but it's okay, I won't count you. And the answer is E. It's the most general case, which is cool, because it actually works for numbers. You put in, 345, and you ask for the second number, returns 4. So you can kind of poke in a number and ask for the digit in the middle of it, which is kind of cool. And also you can give it a long sentence and actually ask for the space or the first letter, the last letter, all that stuff, okay? And combined with length of, if you said letter length of the variable, that can give you the last one, right? The length is 5. If I say, what's the word? 5-letter word. Apple, I guess. And you put in apple for both length of apple, letter length of apple, which is 5. So letter 5 of apple will give you the E. Get it? So you can kind of use length of to kind of gauge that you're going to get the last letter or the middle letter, all that stuff, okay? You can get the middle letter by saying length over 2. Make sense? But it has to be an integer. It can't be like 4.5. So you have to do some rounding to make sure you're snapping to an integer. Okay? All right, so far? What's Michael give me? Oh, my phone's on airplane mode. Oh, good call on that. It's making funny noises. It is making funny noises. That's very good. I'm touching it. I'm on airplane mode. Is it still making noise? I'm also plugged in to this. Maybe I should unplug that. That was bad. That was bad. Okay, good. Good to know that one. This is good stuff. You guys are helping me with the video. All right. So I'll reset this and reset and tip it sideways. Tip it sideways. There we go. Okay. All right. So far we've learned about functions. We've had a couple quizzes. We're moving on. All right. Here we go. Start my video. Take a thing. We're going to have a demo today if I can get time to it. I'm really excited for that. 40. We might be able to fit that in. It'd be great. All right. How are we doing? It's been, continuously. Thank you. Continuously. All right. We're doing okay? Thumbs up there? All right. Here we go. 3, 2. All right. In this video, we're going to learn why you should use functions. I'm trying to motivate why we use functions at all. Okay? So, I'm showing you 3 different snippets of code here. If we zoom in and look at the first snippet of code, what it says is pen down, repeat 4 times, move 25 steps forward, and turn right. So repeat that 4 times to move and turn. What does that do? Draws a square of side 25, right? And you have that code in your code. And then later you want a bigger square. So you have the one in the middle, which says pen down. There's a pen up also. Pen down, repeat 4 times, move 100, turn right. And you have that too. And that draws a larger square of side 100. And in the bottom, you have the third piece of code. And you can see where this is kind of getting annoying, right? All these copies of code, right? The third one is different only in that you move 395. And you ask yourself, isn't there a better way? You ask yourself, isn't there a better way to do this? Why do I have to have 3 separate copies of this code? Couldn't why does the Joy Cooking not have 3 different recipes for milkshakes for 3 different flavors of fruit? Because they say insert fruit here. So the motivation for functions is the following. This is how you generalize that. You generalize it in the same way that Joy Cooking did. They say 1 recipe for milkshake, insert fruit here. Here we say to draw a square. Now we even put a name on it. That's even useful just to help you understand what that block of code did. You gave it a name. And we want to encourage you to use really good names, names that make sense, names that you can use spaces here. This is great. You can even have your argument. You see, there's an argument of length. That can be anywhere. In some other languages, the argument has to be at the end. But because Snap is so cool, you can put that argument anywhere. Kind of cool. So draw a square of side length. And there's a big orange guy. And that orange guy is like the 500 hats of Bartholomew Cubbins, where you keep dragging from that length down, and when you drag it away, it's still there. I'll show a demo a little bit later in the next video. You'll drag it away, it's still there. And you keep taking the hat away, and the hat's still there. Okay, so you can't damage that. And you drag that into where? Well, the one thing that was changing, the 25 or the 100 or the 395, didn't have space or how far to move. So I dragged length down, and now it fills in where the move is, and now you've got a beautiful function that is general, that can draw any size square. Isn't that awesome? So you took 3 copies and you reduced it to 1, and now you have a much more general. Now I want to tell you that as you become more and more sophisticated as a computer scientist, you're going to say, but look, I'm still hard coding some values there. Meaning hard coding some numbers. There are numbers in my code. What are the numbers do I have? Repeat 4, turn 90. How could we be even more general than that? That's only a square. What if we repeat 3 times and turn 120? What do I get then? A triangle. So let's think about how to even be more general than that and add another parameter that is how many sides you want. And now that factors into maybe how many times you repeat and how much you turn each time. Maybe there's some math you have to do to get that right. And now you have a much more general. You shouldn't call it draw square anymore. What should you call it? Draw polygon, exactly. Draw polygon of side length with n sides or something. Okay? And that'll be able to draw any size, square, triangle, regular, hexagon, regular, pentagon. Isn't that great? So you've now made a more general program. That's awesome. So, in general, why we use functions, as I just said in that example, to bring the generalization together so we don't have copies of code. They are building blocks of our program. You now build functions upon functions upon functions. It's really powerful. They can be composed together. Breaking big problems down into smaller ones is called functional programming. And what you're going to see on the left is a composition of code that does something very interesting. Let's look at it together. I wanted to figure out how many years older I am than you. So, somehow me is stored in the me variable. I don't care. Somehow this is a database of me. And you is stored in the you variable. Now watch what I did here. I first called the birthday routine, the innermost block. Birthday of me, birthday of you, returns in whatever way it returns. Here's the beautiful thing. Abstractly, I don't care how it returns it. It can return it as a string. Dan was born on the blah, 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 of blah, 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 blah. Or it could return as a number or something. Whatever the range is, I don't care. Why don't I care? Because as long as the guy receiving that, which is birthday to days since 1900, takes the same format. As long as the plug fits, right? You're like trying to fit a plug into the socket. As long as the plug, the output of birthday, fits into the input of the birthday to days since 1900. As long as they fit together, I don't care what that format is. Isn't that kind of neat? That's kind of neat, right? So that now returns the days since 1900 I've been born. So that's a lot of days for me and fewer days for younger students. Okay? Now I have these 2 days. How do I figure out how many years older I am than you? Well, what if I subtract those days? Now I have the days different from us, right? That's like the days between when I was born and when you were born, okay? Days I was alive until you were born. That's what it basically says, right? That's that days. I take the absolute value of that. Now, regardless of whether you're older or younger than I am, it'll still work, right? If you're older, it's going to be a negative number, or younger, it'll be a smaller number, so a positive number. So it turns out that now makes that a number of days between the two birth dates. Days. And now, how do I figure out the years apart? Divide by 365. And that'll work out to give a fractional amount. Maybe it's 11.5. Maybe I'm 11 and a half years older than you are. But that expression is a remarkable composition of an expression using functions to show you how we compose things together. Isn't that awesome? So, hope you enjoyed that example. Finally, functions are awesome because if you live in a functional programming world, if you only do these functions and never have any commands but only functions, then your work can be parallelized because there's no state, there's no changing. So if I'm, say, taking a list of 1,000,000 things and doubling every number, why couldn't I take each of those things and pass it to a different computer? Now 1,000,000 computers are all doing their work, but because there's no state, they can all operate in parallel, and all return the values in parallel. And now all of a sudden I have a program that's 1,000,000 times faster. Wow, is that cool? And that's how cloud computing works. If you live in a functional world, cloud computing is really easy. It's really awesome and really easy. And many people who are now programming on the cloud are moving all their code to functional models because it's so much easier to program this stuff if you live in a functional world. Isn't that awesome? So, taste of a preview. You're going to see recursion in the future. Recursion means as I'm defining that function, I use myself in the definition. Whoa! How does that work? That's like the chicken or egg thing, right? To make a chicken, you put it, like, is this queer? Who goes first? How does that work? Confusing, and we're going to spend a lot of time making sure you guys learn it in this class. It's going to be awesome, okay? So that's the end of it. I've now, let's see, I think I have, that's the end of it. So now let me close it back by saying recursion is awesome. You've seen about functions. You've seen about why we do them, and I've tried to say it's about the generalization and the composition. It's a big deal, okay? All right? So, 3, 2, thanks. Okay. That was a little bit shaky at the end. Now I can ask any questions, answer any questions about that. And maybe we can I'll redo that little video because that was a little shaky. Yes? Generalization is one of the two pieces of abstraction. Abstraction, as we talked about, has these two angles. We're going to see it actually has more of them, but what you've seen, it has reduced details, which is like kind of like I don't care how the car works, I can just drive it. That's reduced details, I can just use it. And it has the generalization, like I should take multiple concrete patterns and abstract them together, generalize them together into one thing. It's like the 3 milkshakes, a fruit, into one milkshake recipe that has an input. That's the idea. Great question. Yes? Tell me your name again? Ishan, go. Sure. Because there's no state, because there's no like, well, you had some numbers that were halfway done, and then you have to like, it's like, if you try to do a recipe, like do this first, like A equals B plus C. And now A is a different value. And then A equals A plus 1. Well, now A is a little bit bigger than that, but like, you still have these kind of half computations there. That's not the case in functional decomposition. Functional decomposition says, if I have, let's say, a list of many things, and I want to do the same thing to every element in the list, if each one is a function, it's not changing their neighbors. Each one is like, take that value, that's the input to the function I want to do. Let's say square it. I want to square everybody's age in this room, right? Well, if I had a single computer, I'd go, what's your age? All right, take a square it. What's your age? Take a square it. What if I had a computer for every person? Because each person doesn't affect their neighbors at all, each computer could wake up, square that particular person, and put it back in, and we'd be done. Because the function never actually changes a state thing. If the function I want to do is actually changing the world, then it's really bad. Because if she runs before him, then it's really crazy, right? If like she's supposed to add some money to a bank account, and he's supposed to add 1 to it, and then he's supposed to double it, it matters what order you do those things. But in functional worlds, it doesn't matter what order you do them. Because the order can be any order, then parallel stuff works. Because sometimes computers, this computer is faster than that one. Doesn't matter who goes first or who ends first. It's all clean and beautiful. You'll see it later in the class, but it's an easy example. Any more stuff? I have a demo next. Okay, do I have time in my demo? I do. 10 minutes. All right, here we go. Here's my first attempt at a demo. Please bear with me as I see if I can do a demo live on this system. This is going to be great. I hope this works. Okay, I'm moving this. Sorry for something moving here. Okay, go back to my spot. See, this is my spot. See, this is my this. Okay, 3, 2. All right, folks, here's a very quick functions demo. Let's get out of PowerPoint. Let's go into Snap. Snap is in the browser. You want to go into Chrome and make sure your view is saying enter presentation mode. And I'm already in it, so I'm loving it, okay? So now, here's how you make a function. You go to the variables tab in the upper left, and you scroll to the bottom, and there's a make a block button. That make a block button lets you choose, make a block is how we're making those things. So the guys on the left are not things that are just coming down from the mountaintop. You can make your own block and feel very empowered that you can also contribute to the set of blocks that are available. The first thing you do is you ask yourself, what tab do I want the block to live under? This will help you organize yourself. As you're making 100 blocks, you just put them in the one big list. It'll be hard to find things. You put them in a color based on what they're going to do. So if we're going to make a draw square block, we're going to probably say motion. Okay? So you can start typing. By the way, you also want to click on command, which it is defaulted to, and you say draw a square. Look at this. I can put spaces in there. I love it. Okay? And so I'm going to say, let's not have an input for now. I'll show you how to make an input later. And I'm going to say it's a motion block. And watch what happens. It all turns blue. Love that. You say go. And there is your block editor. And you say, but oh, I meant to have an argument there, right? So, and you know it's going to be repeat, which is a control block. And you get a repeat number of times. Okay? Repeat. And there's a clicking sound, which is great. Add the clicking sound if you like that stuff. And you're going to move some number of steps. And you're going to turn 90 degrees. Just make it easy, okay? So, this is going to be draw a square of 100. It's already locked in. So this really should be draw 100 square. And watch, I can actually add, I can go and add a plus here. The plus is normally on your list. I turned the plus off with my settings. I can say size 100, size 100. Watch this. And I just added some words to my title. Isn't that kind of cool? Now, if I hit apply, watch, apply, and I scroll in my motion, look, there it showed up. Draw a size 100 square. Isn't that great? If you want to take that out and say, no, I want to be more general, well, let's first take this out. And let's take, look at this. Take 100 and make it a length. Click on input name. I'm going to say length. I hit OK. And now it's this Bartholomew Cubbins hat. Watch this. I take it away, and it's still there. I take it away, and it's still there. See that? So you could be pulling that out and putting it in many different places. That's an argument. I take this, I drag it into move. Bam. And now, watch. Notice it's still here because I haven't hit apply yet. I hit apply, yoink, and now there's a hole there. Now, the hole is square. Many holes are round because they're numbers. So one subtle thing is you click on this, and I can change it back to a title text if I wanted to. I don't want to do that. I can click this right arrow and tell it this is a little editor that you don't have to use until you get more sophisticated, where you can click number. You can also give it a default input, like default input to 100. Watch this. And now, when I say OK and apply, notice the 100 showed up down the corner, and it's rounder. Just a nice thing for you to use if you want to do that, okay? And it'll say length equals 100. So by default, it's 100, just because it's over there. And now you say, OK. And now we can try this. Let's see if it works. Bink. Didn't work because I didn't put the pen down. That's fine. It's just a move block. So put a pen down before, put a pen up afterwards. And here we see, I'm going to go back here and try this. You click, and did it draw a thing? Let's see if I can zoom out. And there it is. Awesome. One of the things you can learn is you can make this smaller. This is the full size. I'm zooming in, so it's doing something weird. That's the full size stage. That's the half size stage. If you hold shift, the magic shift, it goes to mini stage, the smallest possible stage. So if what you're doing is about programming, not about doing the stage, put the stage out of the way by holding shift down, make it very small. We added that recently. So watch. Now I can change this to be size, we may have to make this kind of half size to see it here. So our size, let's try it, 50. Let's also clear this before, and bink, and there, 50 square. Love it, right? Just love this. Now, you can also make a block by holding Control down, the modifier key, or right-clicking and clicking in the background. And one of these are all hidden menus you can get. All hidden menus. And this is make a block right there. Brings you up to the same thing. Okay? That's awesome. So you can also do that here. If I want to delete that, and I don't want this draw size anymore, I want to get that definition out of there. If I right-click on this, I can say delete block definition. And that undoes the create a block. I made a block, and I now delete a block. Okay? So that demo was how to make a block. Now you're ready to start making blocks, make functions, make reporters. Have some fun, folks. Enjoy. Thanks so much. Woo! All right. Cut.